55 BC, the northern frontier of the Roman world. Gaius Julius Caesar stood on the western bank of the Rhine River, staring across 400 yards of dark, churning water at Germania. Behind him, 8 legions of Roman soldiers, 40,000 men who had conquered Gaul in 5 brutal years of campaigning. Ahead, the unknown. The Germans had been raiding across the Rhine for months. Germanic tribes, primarily the Usipetes and Tencteri, had crossed into Gaul, seeking new lands after being pushed westward by the Suebi, a massive confederation of Germanic peoples who dominated the lands east of the Rhine. These raiders had brought chaos to the Gallic tribes who had submitted to Rome, threatening Caesar's carefully constructed network of alliances and tribute. The Senate expected Caesar to drive the raiders back. His officers expected a pursuit, perhaps a punitive expedition across the Rhine using boats. What Caesar planned instead would shock Rome, terrify Germania, and demonstrate Roman engineering capabilities that wouldn't be matched for over a millennium. He was going to build a bridge, not a pontoon bridge of boats lashed together, the standard military expedient for river crossings. Not a ferry system that would take weeks to move an army across, a permanent timber bridge, strong enough to march 8 legions across in full battle order, built in 10 days. The Roman engineers who received this order thought their commander had lost his mind. The Rhine at this point, near modern Koblenz, was over 400 yards wide, up to 30 feet deep in the centre channel, with currents that could sweep away a swimming horse. The river bottom was soft mud overlaid with stone, making pile driving nearly impossible. The Germans controlled the far shore and would certainly attack any construction effort. And Caesar wanted it done in 10 days. Mamurra, Caesar's chief engineer, a man who had served in earlier campaigns and overseen countless military construction projects, studied the river for 2 days before presenting his design. What he proposed was a masterpiece of Roman engineering that demonstrated why Roman military engineering was the most advanced in the ancient world. The bridge would rest on paired pilings driven into the riverbed at an angle, leaning downstream to resist the current's pressure. Each pair would be locked together with a crossbeam 2 feet thick, creating A-frame structures spaced 40 feet apart across the entire width of the river. Additional pilings would be driven upstream of each A-frame, angled to catch debris and break the force of anything the river threw at the bridge. The roadway would be laid across these frames using heavy timbers, then covered with branches and earth to create a surface suitable for heavily laden soldiers, cavalry, and siege equipment. It was brilliant. It was also theoretically impossible to build in 10 days. Mamurra divided the construction into phases and assigned specific tasks to each legion. The 10th Legion, Caesar's most experienced and trusted unit, received the most critical assignment. They would drive the initial pilings and construct the central span where the river was deepest and the current strongest. If the 10th could build the centre, the other legions could complete the approaches. The men of the 10th Legion were not engineers by training. They were soldiers, recruited from farms and towns across Italy and Cisalpine Gaul. But every Roman legionary was also a construction worker. From their first days of training, Roman soldiers learned to build. They built their marching camps every night, entrenching and palisading an area large enough for their entire unit. They built roads as they marched, creating the infrastructure that would tie the empire together. They built siege works, aqueducts, fortifications, and bridges. The Roman military was as much a construction organization as a fighting force. But this was different. This was building a major river bridge under combat conditions in 10 days. The bridge site became a scene of organized chaos as thousands of men worked simultaneously on different aspects of construction. Timber crews fanned out into the surrounding forests, cutting massive oak trees that would form the pilings. Each piling needed to be at least 18 inches in diameter and up to 40 feet long, cut stripped of branches and sharpened at one end. The cutting crews worked in shifts around the clock, and the forests echoed with the sound of axes biting into wood. Transport teams using oxen and human muscle dragged the massive timbers to the riverbank. A single 40-foot oak log could weigh over a ton, and the bridge would require hundreds of them. The ground from forest to river became a churned morass of mud as logs were hauled into position. At the river, the real engineering challenge began. Driving pilings into a riverbed under 30 feet of fast-moving water required technology that pushed Roman capabilities to their limit. The Romans used a device called a festuca, essentially a massive pile driver, consisting of a heavy weight raised by ropes running through a pulley system, then dropped repeatedly onto the top of the piling. But using a festuca in the middle of a river required building a working platform stable enough to support the device, and the crew operating it. The 10th Legion's engineers constructed floating work platforms using small boats, lashed together and stabilized with anchors upstream and downstream. These platforms, barely stable in the current, had to support not just men but the massive timber pilings and the pile-driving equipment. Getting a 40-foot log weighing over a ton into vertical position on a floating platform in a strong current, then driving it into the riverbed at a precise angle, represented an engineering challenge that would test even modern construction crews. The men of the 10th worked in teams, each focused on a specific task that had to be perfectly synchronized with every other team. The first challenge was positioning. Each piling had to be placed exactly, following Mamura's precise measurements. Roman surveyors used a groma, a cross-shaped sighting device, to establish exact positions from the shore. Teams in boats would plant marker poles at these positions, fighting the current to hold station while the markers were secured. Once a position was marked, the piling team moved in. Getting a massive timber into the water was the first test. The log would be positioned on the bank with one end overhanging the water, then teams on both sides would walk it forward, using ropes and sheer muscle to control its descent. Once in the water, the log had to be manoeuvred to the floating platform, a process that required perfect coordination between the crews on the platform and those controlling guide ropes from boats. With the piling positioned on the platform and held vertical by a wooden frame, the pile-driving crew took over. The festuca's weight, a massive iron-shod timber weighing hundreds of pounds, would be raised by teams pulling on ropes, then released to fall onto the top of the piling. The impact would drive the piling a few inches into the riverbed. Then the weight would be raised and dropped again, and again, and again. Each piling required hundreds of blows to drive it to the required depth. The work was exhausting, dangerous, and had to be done with precision. If a piling went in at the wrong angle, it would have to be extracted and repositioned, wasting hours of work. The noise was constant and overwhelming. The splash and creak of logs being positioned, the rhythmic chanting of the rope teams raising the pile driver's weight, the tremendous boom of the weight striking the piling, a sound that echoed across the water like artillery fire, the shouted commands of the engineers directing each operation, and underlying everything, the rush and roar of the Rhine itself. But the Romans faced a problem that no amount of engineering could solve through technology alone: the riverbed. At some points the bottom was soft mud that piling sank into easily but couldn't grip firmly. At others, there were layers of stone that resisted the pilings no matter how many times the weight was dropped, and throughout the current was constantly trying to shift everything, pulling at the pilings, pushing against the work platforms, threatening to sweep away men and materials. The solution came from experience rather than engineering manuals. Veteran soldiers of the 10th, who had worked on construction projects across Gaul, suggested techniques adapted from civilian bridge building. At points where the mud was too soft, they drove bundles of smaller stakes first, creating a firmer foundation for the main pilings. Where stone layers resisted penetration, they used iron-pointed stakes to break through the stone layer before attempting to drive the main timbers. For extra stability in the current, they added angled bracing pilings upstream of each main support. These weren't in Mamura's original design, but the engineers quickly incorporated them when they saw how effective they were at breaking the force of the current. By the end of the second day, not a single main piling had been fully installed. The work was taking far longer than planned, and Caesar's 10-day deadline seemed impossible. Officers began quietly discussing alternatives, preparing to tell Caesar that the bridge couldn't be built in the time allowed. That's when the competitive nature of the Roman legion system came into play. The 7th Legion, working on the southern approach where the water was shallower and the current weaker, completed their first section of pilings on the morning of the third day. Word spread through the army instantly. The 7th had beaten the 10th to first completion. For the men of the 10th Legion, this was unacceptable. The 10th was Caesar's favourite legion, his most trusted and experienced unit. They had led the assault at virtually every major battle in Gaul. They had broken the Nervi at the Battle of the Sabres. They had stormed the walls of Avaricum. They were the legion that other legions wanted to be. Being beaten by the 7th at any task was a humiliation they would not tolerate. The 10th centurions, the backbone of any Roman legion, immediately reorganized the work schedules. Instead of rotating crews every few hours, they established overlapping shifts that kept work going continuously. Men finishing one task would immediately be assigned to another. Rest periods were shortened. Meals were eaten on the work platforms. The pile-driving crews developed a rhythm, coordinating their rope pulls and releases with the precision of veteran soldiers executing complex battlefield maneuvers. The speed of construction increased dramatically. By the evening of the 3rd day, the 10th had caught up to the 7th. By the morning of the 4th day, they had pulled ahead. The centre section, the most difficult part of the bridge, was taking shape faster than anyone had thought possible. Other legions, inspired by the competition between the 7th and 10th, increased their own pace. The bridge grew from both shores simultaneously, timber by timber, piling by piling, a Roman engineering miracle taking shape in the middle of a German river. But the Germans weren't simply watching. From the eastern shore, Germanic warriors observed the construction with growing alarm. The implications were clear. If the Romans completed this bridge, it meant Roman legions could cross into Germania at will. It meant the Rhine, their primary defence against Roman expansion, had been rendered irrelevant. It meant war. Germanic scouts reported back to their tribal leaders that the Romans were building not a temporary crossing but a permanent structure. The tribes held emergency councils. Some argued for immediate attack, launching boats against the work crews to disrupt construction. Others advocated for ambush, waiting until Roman forces crossed and then cutting them off from retreat. The problem was unity, or rather, the lack of it. The Germanic tribes operated as independent entities, each with its own leaders and interests. Creating a coordinated response required negotiations between tribes who often viewed each other as rivals. While the Germans debated strategy, the Romans worked. The advantage of a unified command structure under Caesar was never more apparent. Every legion knew its task, every cohort its specific assignment, every century its role. Orders flowed down from Caesar through his legates to the tribunes, to the centurions, to the men. The entire construction project operated as a single organism with 40,000 parts working in perfect synchronization. By the 5th day, the basic structure was complete. Paired pilings stood across the entire width of the river, angled into the current, locked together with massive crossbeams. The bridge was beginning to look like an actual bridge rather than a collection of poles sticking out of the water. Now came the next phase, laying the roadway. The decking timbers had to be cut to precise lengths, positioned across the crossbeams, and secured. Each timber was a massive oak plank, cut from the same forests that had provided the pilings. The planks were laid perpendicular to the bridge's length, creating a solid surface that would distribute weight across the entire structure. The work required different skills than piling installation. Instead of brute force, this phase demanded precise carpentry. Each timber had to be shaped to fit perfectly with its neighbours, with no gaps that could catch a hoof or wagon wheel. The planks were secured to the crossbeams using wooden pegs driven through pre-drilled holes, a technique that would allow the entire structure to flex slightly with the current without breaking apart. Teams of carpenters worked their way across the bridge from both shores, laying planks as fast as they could be prepared. Behind them came other crews filling gaps with smaller timbers and adding railings to prevent soldiers from falling into the river during the crossing. The 10th Legion, having completed their piling work in the centre section, moved to the decking phase with the same competitive intensity they had brought to the earlier work. They weren't just building a bridge anymore, they were proving they were still Caesar's best legion. The Germanic tribes finally agreed on a strategy. They would wait until the bridge was nearly complete, then launch a massive raid just as the Romans began crossing. The timing would be critical. Too early, and the Romans could simply defend the western shore. Too late, and Roman forces on the eastern bank would be too strong to dislodge. They assembled a force of approximately 5,000 warriors, primarily from the Sugambri tribe, known as fierce fighters who had raided Roman territories before. The plan was to strike fast and hard, destroying as much of the bridge as possible and killing as many Romans as they could catch on the eastern shore. What the Germans didn't know was that Roman scouts had observed their assembly. Caesar had informants among the Gallic tribes who maintained contact with Germanic peoples, and reports of a large warrior gathering had reached Roman intelligence. Caesar's response was characteristically aggressive. Instead of slowing construction or reinforcing defensive positions, he accelerated the timeline. The bridge would be finished faster and Roman troops would cross before the Germans expected. On the 8th day, the bridge was functionally complete. Not perfect, not finished with all the final details, but strong enough and wide enough to begin moving troops across. The roadway was solid, the structure was stable, and Caesar gave the order. The 10th Legion would cross first. The honour of being first across was appropriate recognition for their work and also practical psychology. If the bridge could support the 10th Legion in full battle gear, it could support anything, and if there was a German ambush waiting, Caesar wanted his best fighters to meet it. The men of the 10th Legion formed up in the early morning of the 9th day. Each soldier carried his standard combat load, about 60 pounds of weapons, armour and equipment. Pilum, the heavy throwing spear that was the primary offensive weapon of Roman infantry. Gladius, the short sword designed for close combat. Scutum, the large rectangular shield that was both defence and weapon. Lorica segmentata, the segmented plate armour that defined the classic Roman legionary. Helmet, sandals, belt, dagger, rations, water, tent sections, stakes for the nightly camp and personal items. Fully laden, each man weighed approximately 200 pounds. The 10th Legion, at roughly full strength of 5,000 men, represented a moving weight of £500,000 of soldiers and equipment. If the bridge could handle this crossing, it could handle anything the Romans might need to transport. Centurion Marcus Petronius stood at the western end of the bridge as his sentry prepared to cross. He had been with the 10th for 12 years, fighting in Spain before joining Caesar's Gallic campaigns. He had crossed rivers before, usually in boats or by swimming in full armour, a terrifying experience that had killed men he knew. This bridge, built by his own legion in 9 days, represented something different. It was Roman engineering and Roman determination made visible, a permanent statement that there were no barriers Rome couldn't overcome. The signal was given, and the 10th Legion began to cross. The lead cohort, 480 men in 6 centuries, marched onto the bridge in column formation. The timber deck covered with branches and earth provided solid footing. The structure barely moved under their weight, testament to the quality of construction. Behind the first cohort, the remaining cohorts followed at measured intervals to distribute the load. The crossing took approximately 3 hours. 5,000 men marching across a 400-yard bridge, maintaining formation, weapons ready, fully prepared for combat if needed. The sound was incredible. 5,000 pairs of hobnailed sandals striking timber in the distinctive rhythm of Roman march cadence. The creak and flex of wood under stress, the rush of water around the pilings, and underneath it all the steady breathing and jingling equipment of an entire legion on the move. When the first soldiers stepped onto the eastern shore, a cheer went up from the western bank that could be heard for miles. The Romans had crossed the Rhine. The impossible had been accomplished. By the end of the 9th day, 3 legions had crossed approximately 15,000 men, occupying defensive positions on the Germanic side of the Rhine. Caesar himself crossed on the morning of the 10th day, making a point of walking slowly across the entire length of the bridge, examining the construction, speaking with the engineer crews who were still making adjustments and improvements. The Germanic attack never came. The Sugambri warriors, watching from concealed positions, saw not a vulnerable construction project but a completed bridge swarming with Roman soldiers. They saw legions forming up in perfect order on the eastern bank, cavalry patrols spreading out into the surrounding territory, and supply wagons beginning to cross with food, ammunition, and equipment for an extended campaign. The tribal council met again and reached a unanimous decision: retreat. Fighting Rome on open ground when Rome had supply lines, reinforcements, and numerical superiority was suicide. The Sugambri and other tribes melted back into the forests, abandoning their villages and taking their families deeper into Germania, where the Romans might not follow. Caesar remained east of the Rhine for 18 days, systematically destroying every village and crop field within a 30-mile radius of the bridge. It was a punitive expedition designed to send a message to all Germanic tribes. Raiding into Gaul would result in Roman retaliation, and the Rhine was no longer a barrier. The legions could cross at will. The psychological impact was enormous. Germanic tribes throughout the region sent envoys to Caesar, pledging peace and offering hostages to guarantee their compliance. The Suebi, the massive confederation that had been pushing tribes westward, withdrew from the Rhine frontier entirely, moving their people east to avoid Roman reach. When Caesar recrossed into Gaul after 18 days, he did something that shocked both Romans and Germans. He destroyed the bridge, not just abandoned it, but systematically demolished the eastern end, removing enough of the structure to make it unusable by any potential Germanic invasion, while leaving the pilings in place as a permanent reminder that Rome could rebuild it whenever desired. The destruction was almost as impressive as the construction. Engineers calculated exactly which supports to remove to render the bridge impassable without weakening the remaining structure. Soldiers worked for 3 days dismantling what they had built in 10, carefully salvaging timbers for future use while ensuring the eastern approach was completely destroyed. The message was clear. Rome could build this bridge any time it wanted. The Rhine was not a defence against Rome. It was merely an inconvenience. The bridge project's impact extended far beyond the immediate military campaign. News of the achievement spread throughout the Roman world, carried by official dispatches, merchant reports, and soldiers' letters. In Rome, the Senate received Caesar's report describing the construction and crossing. The senators, many of whom had never left Italy and had no concept of the Rhine scale, struggled to comprehend the engineering accomplishment. Some accused Caesar of exaggeration. No bridge could be built across such a river in 10 days. The claim was propaganda designed to inflate his reputation, but too many witnesses confirmed the story. Officers from other legions, merchant contractors who supplied the army, Gallic allies who observed the construction, and even Germanic envoys who had seen the bridge firsthand all corroborated Caesar's account. The bridge was real, and it was extraordinary. Roman engineers studied reports of the construction technique, incorporating lessons learned into future military manuals. The paired piling design became standard for Roman military bridges. The organizational approach, dividing construction into parallel tasks assigned to different units, became doctrine for all large Roman engineering projects. The bridge's real significance lay not in the structure itself, but in what it represented. Roman military engineering had reached a level of sophistication that allowed them to overcome any natural obstacle. Rivers, mountains, forests, swamps, nothing could stop Roman expansion if Rome decided to move forward. The Germanic tribes understood this implicitly. Before the bridge, they had viewed the Rhine as a natural boundary that limited Roman power. After the bridge, they knew there were no boundaries, only temporary obstacles that Rome could overcome with sufficient will and organization. The Gallic tribes drew similar conclusions. Any thoughts of rebellion had to account for Rome's ability to move forces quickly across terrain that should have been impassable. The Rhine Bridge demonstrated that Roman logistics and engineering could support military operations anywhere. A year later, in 54 BC, Caesar built a second bridge across the Rhine, this time in only 10 days from start to finish. The second bridge incorporated improvements learned from the first, and construction crews now experienced with the technique worked even faster. Again, Caesar crossed with his legions, conducted a punitive campaign against Germanic tribes, and destroyed the eastern end of the bridge before withdrawing. The second bridge proved the first wasn't a unique achievement but a repeatable capability. Rome could cross the Rhine whenever military necessity required. The engineering principles demonstrated at the Rhine would be applied throughout the expanding Roman Empire. River bridges built using similar techniques would span the Danube, the Rhone, the Thames, and dozens of smaller rivers across Europe, North Africa, and the Middle East. Each bridge represented the same fundamental truth. Roman organization, engineering knowledge, and disciplined labor could accomplish what others thought impossible. The men of the 10th Legion, who had driven those first pilings into the Rhine's muddy bottom, who had worked around the clock through injury and exhaustion to complete their section of the bridge, who had marched across first to prove the structure's strength, carried the memory of that achievement through the rest of their military careers. Many would retire after completing their service, receiving grants of land in newly conquered territories. They would build farms and towns, raise families, and tell stories of their time in the legions. And when they told those stories, one achievement always stood out. The time they built a bridge across the Rhine in 10 days and marched an army into Germania. The bridge itself, destroyed by Roman hands after serving its purpose, left minimal physical trace. The pilings rotted, the timbers were salvaged or washed away, and the Rhine returned to its natural state. But the memory remained, embedded in Roman military doctrine, preserved in Caesar's written accounts, and passed down through generations of soldiers who learned that Romans didn't see obstacles, only engineering problems waiting to be solved. Germanic oral traditions also preserved the memory, telling stories of the bridge that appeared as if by magic, allowing Roman legions to cross into their lands without using boats. For Germanic peoples, the bridge became a symbol of Roman power and the futility of relying on natural barriers for defence. The psychological impact lasted for generations, influencing Germanic strategy and tactics in their long conflict with Rome. 2,000 years later, archaeologists and historians still debate the exact location of Caesar's Rhine Bridge. The river has shifted its course multiple times over the centuries, and any physical remains are buried under meters of silt or have long since washed away. But the achievement itself is undisputed, documented in Caesar's own writings, corroborated by other historical sources, and consistent with everything we know about Roman engineering capabilities. Modern engineers analysing Caesar's description of the bridge construction have concluded that the project, while extremely difficult, was achievable with Roman technology and organisation. Computer models of the bridge design confirm that the structure would have been stable and strong enough to support the loads Caesar described. Analysis of Roman construction techniques from other projects demonstrates that the legions possessed the skills and tools necessary for the work. The 10-day timeline, initially dismissed by modern skeptics as impossible, is actually consistent with what a large, well-organised workforce could accomplish given proper planning and continuous work shifts. The Rhine Bridge represents a perfect intersection of Roman strengths. Military discipline provided the organisation necessary to coordinate thousands of workers on a complex project. Engineering knowledge accumulated over centuries of Roman construction experience provided the technical foundation. Competitive spirit, both between legions and within units, drove men to work beyond normal human limits. And strategic vision, Caesar's understanding that sometimes a demonstration of capability is more valuable than immediate military action, turned an engineering project into a weapon of psychological warfare. The bridge also exemplifies Roman pragmatism. Caesar didn't cross the Rhine because he intended to conquer Germania. His strategic focus remained on consolidating control of Gaul, and he had no intention of overextending his forces in the vast Germanic forests. But he recognised that Germanic raiding threatened Gallic stability, and that threat had to be eliminated. Rather than fighting a series of battles chasing Germanic raiders, Caesar chose to demonstrate that Rome could reach into Germania whenever necessary. The bridge made that demonstration impossible to ignore. By building it, using it, then destroying it, Caesar showed that the Rhine was no defence, that Rome controlled the crossing, and that future raids would be met with devastating retaliation. The Germanic tribes understood the message perfectly. The raiding stopped. For the soldiers who built the bridge, the experience was transformative. They had been told to do something impossible and had succeeded through skill, determination, and coordination. That success reinforced their identity as Roman legionaries, members of the most capable military force in the world. The pride they felt in that achievement sustained them through the brutal campaigns that followed. The Rhine Bridge remained unique in Roman military history. No other river crossing project matched its scale, speed, or strategic impact. Other bridges would be larger or longer lasting, but none would be built so quickly under such difficult conditions for such clear psychological effect. In the history of military engineering, Caesar's Rhine Bridge stands as one of the supreme achievements, a perfect demonstration of how technical capability, organizational discipline, and strategic vision can combine to accomplish the impossible. The bridge existed for only 18 days, but its impact lasted for centuries, changing how Rome viewed natural obstacles and how Rome's enemies viewed Roman power. The 10th Legion would go on to fight in many more battles, earning additional honours and suffering terrible losses. They would participate in Caesar's civil war against Pompey, fighting at Pharsalus where they helped secure Caesar's victory. They would serve in Africa and Spain, pursuing the last remnants of senatorial resistance. And throughout all these campaigns, veterans of the Rhine Bridge would tell new recruits about the time they built the impossible, when they proved that Roman soldiers could do anything their commander asked, when they showed the world that rivers were just temporary inconveniences on Rome's march to dominion. The bridge over the Rhine, built in 10 days by the 10th Legion and their comrades, remains one of history's great engineering achievements. Not because of its size or permanence, but because of what it represented: Roman power, Roman capability, and Roman will made manifest in timber and iron, spanning a river that was supposed to be impassable, proving that for Rome, nothing was impossible if sufficient organisation and determination were applied. The Germans had thought the Rhine would protect them. The Gauls had thought distance and terrain limited Roman reach. Caesar's bridge taught both peoples that Rome recognised no limits, accepted no barriers, and would overcome any obstacle through the combined power of engineering, discipline, and military force. When the 10th Legion marched across that bridge on the 9th day of construction, they weren't just crossing a river. They were demonstrating that Roman legionaries were more than soldiers. They were builders, engineers, and the physical embodiment of Roman ambition. They could fight, they could build, they could overcome any challenge, and they would not be stopped by rivers, forests, or any other natural obstacle. The Rhine Bridge lasted only 18 days before Caesar destroyed it. But the memory lasted forever, a permanent reminder that Rome could do the impossible, and that Roman soldiers were the most capable fighting force the ancient world had ever seen. The legacy of the Rhine Bridge extended into every aspect of Roman military doctrine for centuries after Caesar's death. When Augustus reorganized the Roman military following the civil wars, the engineering capabilities demonstrated at the Rhine became formalized requirements for legion training. Every legion maintained a cadre of trained engineers, carpenters, and surveyors who could replicate Caesar's achievement if needed. The knowledge was systematically preserved and expanded. During Trajan's Dacian Wars in the early 2nd century AD, Roman engineers built an even more impressive bridge across the Danube River. The Trajan's Bridge, designed by Apollodorus of Damascus, used stone pilings and wooden superstructure spanning over 3,700 feet, making it the longest arch bridge in the ancient world for over 1,000 years. But that achievement was built on the foundation established at the Rhine. The organisational principles, the division of labour, the competitive motivation between units, all derived from lessons learned during those 10 days in 55 BC. Roman military manuals compiled in the centuries after Caesar's campaigns included detailed instructions for rapid bridge construction based explicitly on the Rhine model. Vigesius, writing his military treatise in the late 4th century AD, described the proper techniques for river crossing operations and specifically referenced Caesar's Germanic campaigns as the exemplar of how such operations should be conducted. The Rhine Bridge had become not just history but doctrine, a permanent part of Roman military knowledge passed down through generations. The impact on Germanic peoples was equally long-lasting and far more traumatic. The bridge shattered any illusion of safety behind natural barriers. Germanic tribal confederations that formed in the centuries following Caesar's campaigns always had to account for Rome's ability to project force across the Rhine. This reality shaped Germanic military strategy, settlement patterns, and diplomatic relations with Rome for 400 years. When Marcus Aurelius fought the Marcomannic Wars in the 160s and 170s AD, Germanic tribes still remembered the lesson of Caesar's bridge. Roman ability to cross rivers at will meant that Germanic strategy had to focus on mobility and guerrilla tactics rather than static defense of river lines. The psychological impact of that 10-day construction project echoed through centuries of conflict. The engineering achievement also influenced Roman civil construction. The techniques developed for military bridges were adapted for permanent civilian infrastructure. The principles of paired piling construction, angled bracing against current, and modular timber deck systems appeared in bridges throughout the empire. Engineers who had served in the legions brought their military training to civilian projects, and the line between military and civil engineering blurred into irrelevance. All Roman engineering was imperial engineering, serving the dual purpose of commerce and conquest. Consider the scale of what the 10th Legion accomplished in context. Modern engineers with powered equipment, prefabricated materials, and detailed hydrological surveys typically require months to build a comparable bridge. The US Army Corps of Engineers, probably the closest modern equivalent to Roman military engineers, estimates that constructing a 400-yard tactical bridge over a major river would require several weeks of work by a specialized engineering battalion equipped with modern machinery. The Romans did it in 10 days with hand tools, human and animal muscle power, and no detailed prior survey of the river bottom conditions. They worked without safety equipment, without electrical power, without motorized transport, without steel cables or modern fasteners. Every timber was cut with axes and handsaws. Every piling was driven by human muscle raising and dropping weights. Every measurement was taken with simple sighting devices. Every problem was solved through experience, ingenuity, and brute force. The casualty rate during construction was never explicitly recorded, but it must have been significant. Men fell from working platforms into the fast-moving water and drowned, weighed down by their equipment. Others were crushed by falling timbers or injured by the pile-driving equipment. Some probably died from simple exhaustion, working day and night in cold water with minimal rest. These deaths were considered acceptable losses, part of the cost of accomplishing the mission. Roman military culture didn't waste lives unnecessarily, but it accepted that significant achievements required significant sacrifice. The 10th Legion's soldiers understood this calculus. They were professionals who had volunteered for military service knowing the risks. Death in combat was expected and honourable. Death during construction work was less glorious, but equally accepted. The mission mattered more than individual survival, and completing the bridge on time mattered enough to justify pushing men to their absolute limits. This willingness to accept casualties in pursuit of engineering objectives gave Rome a massive advantage over enemies who lacked similar discipline. Germanic warriors were individually fierce and brave, but Germanic tribes couldn't organize labour on the scale required for major engineering projects. They couldn't maintain the sustained effort necessary to drive hundreds of pilings into a riverbed while working around the clock in hostile conditions. They couldn't accept the casualties inherent in such work while maintaining unit cohesion and morale. The bridge demonstrated that Roman military power rested not just on superior tactics or equipment, but on superior organisation and discipline. A Roman legion could fight, march, build fortifications, construct bridges, dig siege works, build roads, and perform any other task their commander required. This versatility meant that Roman armies carried their own infrastructure with them, reducing dependence on local resources and allowing operations in territories where other armies would starve or become immobilized. Germanic armies, by contrast, were purely combat forces. They could fight brilliantly in ambush or raid situations where their mobility and knowledge of local terrain provided advantages. But they couldn't sustain extended campaigns because they lacked the logistical organization to support large forces in the field. They couldn't conduct siege warfare because they lacked the engineering capability to build siege works. And they couldn't prevent Roman invasions because they couldn't destroy Roman bridges or fortifications faster than Romans could build them. This organizational asymmetry, more than any superiority in weapons or tactics, explains Roman military dominance in the ancient world. Rome didn't always have better soldiers or better generals than its enemies, but Rome always had better logistics, better engineering, and better organizational systems for converting resources into military capability. The Rhine Bridge crystallized this advantage in a single dramatic demonstration. In 10 days, Roman soldiers built something that Germanic tribes couldn't have built in 10 months with their entire population mobilized. The message was clear and terrifying. Rome could reshape geography itself to suit military necessity. Caesar understood the propaganda value of this achievement perfectly. His written account of the Gallic Wars, the Commentari de Bello Gallico, devoted considerable attention to describing the bridge construction in technical detail. This wasn't just historical record-keeping, it was advertisement, a deliberate showcase of Roman capabilities designed to impress readers in Rome and intimidate potential enemies throughout the known world. The description worked. When Roman aristocrats read Caesar's account of the bridge, they gained pride in Roman achievement and confidence in Roman military power. When foreign ambassadors and hostages in Rome read the same account, often as part of their education in Roman culture, they learned that resisting Rome was futile. Natural barriers offered no protection. Geographic advantages meant nothing. Rome could go anywhere, do anything, overcome any obstacle. This psychological warfare through engineering demonstration became a standard element of Roman imperial strategy. Hadrian's Wall in Britain, the Antonine Wall further north, the fortified limes along the Rhine and Danube all served military purposes but also functioned as propaganda. They demonstrated Roman power to build massive structures in hostile territories, permanent stone declarations that Rome controlled these frontiers and would defend them with unlimited resources. But none of these later achievements matched the pure dramatic impact of Caesar's Rhine Bridge, because none were built so quickly under such difficult conditions for such obvious psychological effect. The permanence of Hadrian's Wall is impressive, but it was built over years by large garrisons in relatively stable territory. The Rhine Bridge was built in 10 days by combat soldiers in the middle of a military campaign with enemies watching from the opposite shore. Speed was essential to the achievement's impact. If the bridge had taken months to build, Germanic tribes would have had time to organize effective opposition. The Romans might have completed it eventually, but at much higher cost and with less impressive results. By building so quickly, Caesar transformed construction into a weapon of shock and awe that paralyzed enemy decision-making. Modern military analysts studying the Rhine Bridge campaign have identified several factors that enabled the rapid construction. First, Caesar had accurately assessed both his army's capabilities and the engineering challenge. He didn't promise something impossible and then fail. He set a deadline that was extremely difficult but achievable, then provided the resources and organization necessary to meet it. Second, the competitive culture within Roman legions provided powerful motivation. Making the task a contest between legions and between units within legions tapped into soldiers' pride and desire for recognition. The men of the 10th Legion didn't work themselves to exhaustion just because they were ordered to. They did it because they refused to let another legion beat them. Third, Roman engineering knowledge was broadly distributed throughout the military hierarchy. While Mamurra designed the bridge, centurions and ordinary soldiers had enough construction experience to solve problems independently, without waiting for orders from above. This distributed expertise allowed rapid adaptation when unexpected challenges emerged. Fourth, Roman supply systems ensured that necessary materials and tools were available when needed. The legions carried engineering equipment as standard kit, including axes, saws, ropes, pulleys, and iron components for the pile-driving machinery. They didn't have to requisition special equipment or wait for supplies to arrive. Everything needed was already present with the army. Fifth, Caesar's strategic positioning gave him time and security for the project. The river crossing site was in territory controlled by Rome's Gallic allies, so construction crews worked without immediate threat of attack. The Germans could observe but couldn't effectively interfere until the bridge was complete, by which time it was too late. These factors combined to create a perfect storm of capability, motivation, resources, and opportunity. Remove any single element, and the achievement becomes significantly more difficult or impossible. This is why the Rhine Bridge remained unique. Rarely did all necessary factors align so perfectly. The human cost of the achievement, never fully recorded, must have been substantial. Building the bridge required approximately 100,000 man-hours of labour, based on modern engineering estimates. This work was compressed into 10 days, requiring thousands of men working around the clock. The physical demands were extreme, men standing in cold water for hours at a time, crews hauling massive timbers through mud, teams raising and dropping pile-driving weights hundreds of times per piling, all while maintaining the mental focus necessary for precision work where mistakes could be fatal. Some men would have died from drowning after falling from work platforms, others from being struck by falling timbers or equipment. Some probably died from hypothermia after extended exposure to cold water, others from simple exhaustion, their hearts giving out under the sustained physical stress. Still others from accidents inherent in working with massive weights and heavy equipment. Roman military culture didn't memorialize these deaths because they weren't combat casualties. No monuments listed the names of soldiers who died building the Rhine Bridge. No honours were awarded posthumously to men killed by falling timbers. These deaths were considered occupational hazards, unfortunate but inevitable consequences of military service. The soldiers who died during construction were buried quietly, their personal effects distributed to their heirs, and their names forgotten by history. This seems callous by modern standards, but it reflected Roman priorities. Honour came from combat, from facing the enemy, and prevailing through courage and discipline. Death in construction accidents, while regrettable, wasn't heroic. It was just bad luck. The distinction seems arbitrary to modern sensibilities, but it was fundamental to Roman military culture. Yet those unnamed dead, crushed by timbers or drowned in the Rhine, were as essential to the achievement as the soldiers who marched across the completed bridge. Without their sacrifice, without the willingness of Roman soldiers to accept casualties even during construction work, the bridge couldn't have been built on Caesar's timeline. The achievement rested on a foundation of anonymous deaths that Roman culture didn't consider worth recording. The soldiers who survived carried physical reminders of the work for the rest of their lives, hands permanently scarred from rope burns, backs damaged from hauling heavy loads, hearing loss from the constant noise of pile driving. These injuries, like the deaths, weren't considered worthy of special recognition. They were simply the price of military service, accepted without complaint by men who understood that Rome's power depended on their willingness to endure. When the 10th Legion marched across the completed bridge, they marched over the unrecorded graves of comrades who had died building it. This was the reality of Roman military achievement. Glory and tragedy intertwined inseparably, with the tragedy deliberately minimized or ignored to preserve the glory's luster. Caesar's account of the bridge construction mentioned none of this. His description focused on technical details and strategic implications, presenting the achievement as a triumph of Roman engineering and organization while glossing over its human cost. This wasn't dishonesty exactly. It was selective emphasis, choosing to highlight aspects that supported his political objectives while omitting details that might diminish the achievement's impressiveness. Modern historians reading Caesar's account must read between the lines, inferring from construction details what he chose not to state explicitly. The number of men required for specific tasks implies casualty rates. The timeline suggests working conditions that would inevitably produce accidents. The scale of timber movement implies injuries from mishandled loads. None of this is stated directly, but all of it can be deduced from what is described. This gap between achievement and cost, between public glory and private suffering, characterized much of Roman imperial expansion. The empire was built by men whose names history never recorded, who died in anonymity so that Rome could project power across the known world. The Rhine Bridge was just one small example of this larger pattern. 10 days of construction that epitomized centuries of Roman conquest. The Germanic peoples watching from the eastern shore understood this implicitly. They saw not just a bridge, but a massive expenditure of human effort. Thousands of men working themselves to exhaustion to build something that would be destroyed weeks later. To Germanic thinking, shaped by tribal cultures with limited labour surplus, this was incomprehensible. Why spend so much effort on something temporary? Why accept so many casualties for something that wasn't even permanent? The answer lay in Roman political economy and imperial ideology. Rome had population and resources to spare. The empire could afford to expend massive labour on temporary projects because those projects served strategic purposes that generated long-term returns. The bridge cost some lives and enormous effort, but it secured Gaul's northern frontier, intimidated Germanic tribes into peace, and demonstrated Roman capabilities to the entire known world. These benefits far outweighed the costs in Roman strategic calculation. Germanic tribes, operating with much smaller populations and more limited resources, couldn't afford such expenditures. Every warrior who died represented a significant loss to tribal military capability. Extended labour projects pulled men away from hunting and raiding, reducing the tribe's ability to sustain itself. Germanic culture optimized for efficiency and conservation of resources because tribes operated close to subsistence margins. Roman culture, backed by the agricultural surplus of Italy and the Mediterranean provinces, could afford inefficiency in pursuit of psychological impact. The bridge was inefficient if measured purely by cost-benefit analysis of river crossing capability. Boats would have been cheaper and easier. But the bridge's value lay not in its transportation utility, but in its demonstration of Roman power. That demonstration was worth any cost because it prevented future conflicts through intimidation. This fundamental difference in strategic culture, Romans willing to expend massive resources on psychological warfare while Germanic tribes focused on immediate material benefit, explains much about the long-term trajectory of Roman-Germanic relations. Rome could afford to lose battles and still win wars because Roman resources were essentially unlimited from a Germanic perspective. Germanic tribes, by contrast, couldn't afford even victorious battles if casualties were high because their manpower couldn't be easily replaced. The Rhine Bridge demonstrated this asymmetry perfectly. Rome built an impressive bridge, used it briefly, destroyed it, and lost nothing strategically because the empire had unlimited capacity to build another whenever needed. The Germanic tribes, having watched the construction and recognized their inability to prevent it or replicate it, lost strategically without fighting a single battle because they learned that the Rhine offered no protection against Roman power. Caesar's genius lay in recognizing that sometimes the most effective military action is the one that wins without fighting. Building the bridge and marching into Germania intimidated the tribes into peace more effectively than military campaigns would have. Combat would have required sustained effort, produced Roman casualties, and left Germanic resistance intact even if defeated. The bridge broke Germanic willingness to resist without requiring significant combat, achieving strategic victory through engineering demonstration. This approach, using engineering and logistics as weapons of psychological warfare, became characteristic of Roman imperial strategy. Later emperors and generals would employ similar tactics, using massive construction projects in frontier regions to demonstrate Roman power and intimidate potential enemies. The message was always the same: Rome could build anything, go anywhere, overcome any obstacle. Resistance was futile because Roman resources and capabilities were unlimited. The Rhine Bridge remained the purest example of this strategy because it combined maximum impressiveness with minimum permanence. Later Roman frontier fortifications were more massive and longer lasting, but they were built slowly over years in pacified territories. The Rhine Bridge was built in 10 days in hostile territory, right in front of the enemy, then deliberately destroyed to prove that Rome didn't even need to keep it because Rome could build another whenever desired. This casual attitude toward massive engineering projects, build it, use it, destroy it, rebuild it if needed, projected power more effectively than permanent structures could. It suggested resources so vast that even impressive achievements could be treated as disposable. This was psychological warfare at the highest level, using abundance itself as a weapon against enemies who lived close to subsistence. The soldiers who built the bridge probably didn't consciously understand this strategic dimension. They understood that Caesar wanted the bridge built quickly, that their legion's reputation depended on meeting the deadline, and that failure was unacceptable. The broader implications of their work, how it fit into Roman imperial strategy and psychological warfare against Germanic peoples, likely never occurred to most of them. But they understood pride in craftsmanship and unit achievement. When the 10th Legion completed their section of the bridge ahead of schedule, despite working on the most difficult part, when they marched across first to prove its strength, when they stood on Germanic soil having accomplished something previously considered impossible, they felt the satisfaction of having exceeded every expectation. That satisfaction sustained them through the brutal combat and grinding marches that characterized military service in Caesar's legions. Years later, veterans of the Rhine Bridge would tell their stories in taverns and retirement communities throughout the empire. They would describe the cold water, the constant danger, the exhausting labour, the competition with other legions, and finally the moment of triumph when thousands of men marched across their completed work. These stories became part of Roman military folklore, passed down through generations, embellished and romanticized but preserving the essential truth that Roman soldiers could accomplish anything their commanders demanded. The Rhine Bridge, built in 10 days by the 10th Legion and their comrades, destroyed after 18 days of use, leaving no permanent physical trace, nevertheless left an indelible mark on history. It changed Roman military doctrine, Germanic strategic thinking, and the broader perception of Roman capabilities throughout the ancient world. It demonstrated that Roman power rested not just on military prowess, but on engineering capability, organizational discipline, and unlimited resources deployed with strategic intelligence. When modern military historians study Roman warfare, the Rhine Bridge features prominently as an example of engineering used as a weapon, of logistics as a force multiplier, of psychological operations conducted through infrastructure demonstration. Military academies around the world still teach the campaign as an example of how to achieve strategic objectives through non-combat means, how to leverage technical capabilities for psychological impact, and how to organize large workforces for rapid completion of complex projects. The bridge exists now only in texts and imagination, but its influence persists wherever military forces attempt to overcome natural obstacles through engineering, wherever commanders recognize that sometimes building something impressive wins more decisively than fighting, and wherever soldiers understand that their role extends far beyond combat to include construction, logistics, and any other task required by military necessity. The 10th Legion's 10-day achievement at the Rhine set a standard that has never been surpassed, a permanent reminder that with sufficient discipline, organization, and determination, no obstacle is truly insurmountable.